Good morning, everyone. It is finally time for us to be going, really doing a crash course in division. We're going to do this for the next few days before Christmas, and then we'll get into fractions after Christmas. I want to kind of take you through what they have learned in third grade leading up to this, and then what we are learning, and kind of how it connects to what we learned. We, as in the adults, what we learned back in school. They will eventually get to that, of course. But this year, once again, just like almost everything else, we're kind of doing some prerequisites for that. So, let's see. So, first thing to note is the relationship between multiplication and division. In the past, students, if they know their math facts, we've learned about fact families. Basically, fact families is just the fact that multiplication and division are related. So, like 2 times 4 is 8, but so is 4 times 2. And if 2 times 4 is 8, then that means also 8 divided by 4 equals 2. And if 4 times 2 is 8, then that means 8 divided by 2 is 4. Okay, these are fact families. You can do that with addition and subtraction as well. But students need to understand this, this concept that multiplication and division are exact opposites. With multiplication, you are taking smaller groups and combining them into a larger group. With division, ultimately what you're doing is you're taking a larger group and then you're sharing it equally among smaller groups. For example, we have 2 of something. Let's say there's 2 kids, they each have 4 cookies, so there's 8 cookies total. Here, there are 8 cookies, and they're divided among 4 students, and so each student gets 2 cookies. All word problems really help with these concepts, but that's a general overview of that. Well, in third grade, some things that they learned to help them understand this concept. Let's say they were given 8 divided by 4. A way they would solve this is they could think that this 4 here represents the number of people this is being shared with, or the number of groups the 8 is going to be broken into. One way we could do this is we could take 8 and we could subtract 4 from it. Actually, no, I'll do that in a second. One thing they would do is they would say, all right, I have 4 groups. Okay, I'm back. My board was shutting off. I had to go catch it before it went off. Okay. So 8 divided by 4. We have 4 groups that we're sharing 8 of something equally among. Let's go back to our cookies. I had a cookie earlier, so it's on my mind. I have 8 cookies total. I'm going to represent them using these dots. These dots represent my 8 cookies. Well, I can give 1 dot to this one, and it's gone. I can give another dot to this one, a dot to this one, and a dot to this one. Now, each group has 1 dot, so that's fair, it's equal. And students understand this concept really well, especially in 4th grade, because they start to kind of really be serious about justice and things like that, and fairness. So they understand that each of these are equal. However, we haven't gotten rid of all 8 yet, so we need to do that as well. So we want to stop and think, can I give equally 1 of these away to each student? Yes, I can, or each group. So I'm going to take 1 and give it here, 1 and give it here, 1 and here, and 1 here. So now we have 4 equal groups, and each group has 2 in it. So we have 2 here, 2 here, 2 here, and 2 here. And when we add those together, 2, 4, 6, 8, we have 8. So we have our total. But this means that 8 divided by 4 equals 2. Okay. Another way to represent that, let's go back to what I was doing up here. You could take away 4 from 8, and that leaves you with 4. And then you can take away another group of 4 from that, and you're left with 0. So you've gotten rid of everything. This is one group of 4, G standing for group, and this is another group of 4. When we add these together, we have 2. So 2 groups of 4 can come out of 8, therefore 8 divided by 4 equals 2. Okay, now we're going to be working with much larger numbers than this, but that is kind of a general overview of that. However, when we get to these larger numbers, it's not very efficient to do this. If you do 247 divided by 5, you could draw 5 groups and then put 247 individual dots in each, or across the 5 groups, but that is going to take forever, and then after you have done that, it's not going to be, unless you have organized it really well, not going to be easy to read. So we want something more efficient. So you could do this as well. You could do 247, take away 5, 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 but it's going to take up a whole sheet of paper and a whole lot of time. So there's got to be something more efficient. So what we do is something called the partial products method, or sorry, no, the partial quotients. Partial products was for multiplication. This is going to look kind of like long division that we're used to, but I'll talk about why it's not. First, I'll just go through and kind of show how we used to do it, or how I learned. So 247 divided by 5. We set up 247 under the house. We have 5 over here. That's our number of groups. So I would say, okay, how many times can 5 go into 2? None. So I'll look at the next number. 24. Can 5 go into 24? Yes. How many times? 4 times. So we put a 4 up here. And I put 20. And I subtract, and we have 4, and we put 7 over here. Bring it down. How many times can 5 go into 47? 9 times. So I put the 9. I put its product. Take it away. And at this point, in 4th grade, if there is a remainder, we just leave it as a remainder. As they move on, this will become decimals. But for now, all they would do is they would say 49 with a remainder of 2. However, what happens if a student does not know their multiples? Well, they may say, well, I know I can take one group of 5 out of here, and they'll put 1 here. Well, 1 times 5 is 5. And then they subtract, and then they've got 19 left. Okay, well, then they can go, well, 5 can go into 19 3 times, but then where does the 3 go? What do we do with that? If a student doesn't know their multiples, this doesn't work well. And so the strategy that I'm about to show you allows them to have some experimentation in order to teach them how to get so efficient that they can do this. But because most of them don't think as efficiently as they need to for this. So what we're going to do, we're going to set it up similarly. It's going to look like the long division method or the house method, except we're going to draw a line down this way. Had to pause again. Had somebody come and visit my room for a second, pick up some papers. But anyway, back to this. So we're going to set it up similarly to this. However, we have a lot of room for experimentation here. So another thing, though, that's going to help with this is to not think of this as 2 and 4 and 7. But as we've talked about in the past, think about these according to place value. This is 200, this is 4 tens or 40, and this is 7 ones. So 5 into this 2, or 5 into the 24, it's not actually 5 into 24, it's 5 into 240. This 4 is 40, so 5 goes into 240 40 times. And so then 5 times 40 would be 200. And so we're actually subtracting 200 from 247. And that's why we have 47 left over. Anyway, so that will be seen over here. So if a student is thinking clearly, they can think about this as 247 and thinking efficiently. And they can say, well, this is 200. How many groups of 5 can I take out of 200? And they might not know. They might not know that answer because they probably only know like 5 times 10, 5 times 11, 5 times 12 maybe. I know that 5 times 20 is 100, but the kids probably don't know that, so they wouldn't think to use that. But what they do know is, let's say, 5 times 10, or even we can do 5 times 1. And I'm just going to do 5 times 1 to show that theoretically we could do that. So I could take one group of 5 out of 247. So I'm going to write 5 under here, and I'm going to subtract it. This kind of goes back to our method like this. This is called repeated subtraction, but this is a more advanced version of that because we can use groups. So 247 minus 5, we are left with 242. Well, a student could do this 49 times if they wanted to. But again, it's going to take forever, take up a whole lot of space. So at this point, hopefully they go, yeah, maybe I'm going to think of a multiple of 5 rather than doing just 5 times 1 every time. And they're going to choose a different multiple of 5. We do want to, right here, put how many groups of 5 this is. So this is one group of 5. One group of 5. I'm not going to write G of 5 on every one, but I will put a parentheses here so that we know that what these are, that these represent our groups of 5. So now we might say, I want to think of a bigger group of 5. We could do 2 groups of 5, which is 10. But I'm going to think ahead and say, well, that's just going to give me 232. So I'm still going to have a whole lot of that. So let's think of a larger group of 5. Well, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Some of them might even know 55, 60. Well, that's 12 groups of 5. So that's the largest one they know. So they could say, hey, I'm going to take 60 away, and that's going to be 12 groups of 5. When I do that, I am left with 182. Let me check that. Yep, okay. Just had to be sure. So 182. Now, they could keep doing this. They could take another group of 60 away, or if they knew a more efficient strategy, they could take 60 away, and that'd be another 12. Or some of them might even think really efficiently and say, well, I know that 60 times 2 is 120, and I can take that from here. Or even 60 times 3 and take it 180 away. And that would be, lost my train of thought. 5 times 12 is 60, so then 2 times as much as that would be 24, 120. Not every kid is going to think of that, so I'm just going to say, let's do another group of 12. So take away 60 from that. We are left with 122. So now we're getting closer. This is another 12. 5 times 12 again gives us 60, and they could keep doing this until they get to their total. I'm going to take away 60, left with 2. Okay, great. So now we can't take any more groups of 5 away without going into the negatives. But how do we find the answer? Well, it's over here in the groups, the number of groups. We took away 1 group, then we took away 12 groups. I'm going to do 12, 24, 36, 48, plus 1 gives us 49. So then they would know that 247 divided by 5 gives us 49 groups of 5, and we're left over with a remainder of 2. Okay? This is not the only way they could do this. Like I said, there are plenty of ways they could solve this. If a student is thinking so efficiently that they can go, okay, well, I know that 5 times 12 is 60, and double 60, they could say 5 times 12 is 60. So then 60 times 2 would be 120. 120 times 2 would be 240. You can say, hey, 240 is a multiple of 5. I just need to figure out how many times it is. So 60 is 12. 120 is twice that, so 24. And then twice that would be 48. So I can take 48 groups of 5 out of 247. They just write 48 over here, and they're left with 7. We can take one more group of 5 away. You add 48 plus 1 gives you 49. And you have a remainder of 2. The beauty of the partial quotients method is that there is not just one correct answer. This is the same thing we did over here, basically. We took away 40. Well, actually, no, it's not. We could say 5 times 40 is 200. So let me actually do it exactly like that. So 247. That's what I was trying to do, but got off. Okay, here we did, remember this 247, this is not just a 2, it's 200, okay, and we can't take, we could take 5 out of 200, but here, when we're thinking of this, you can't take 5 out of 2, so you go over to here, and you think 24, but this is actually 240, so how many times can 5 go into 240? Well, down here, it can go in, so no, I want to do 200, I'm doing the same thing again. So 5 times 4 is 20, so 5 times 40 would be 200, we take away 200, we're left with 47. So 40 groups of 5 over here, we're left with 47. We can take 9 groups of 5, which is 45, away from that, leaving us with 2. And so this is the same thing as this, and you just add your 40 and your 9, you get 49 with a remainder of 2. This would be one of the most efficient ways. These two are the most efficient ways, but again, students don't always think efficiently, and they're not always super comfortable with multiplying by tens and hundreds and thousands and things like that. So this is a great way to experiment. I'm going to show you one more because we are supposed to go up to the thousands. So let's say I have 4,876 divided by 7. Again, we know the way that we used to do it. But here, what we could think is, well, how many thousands are there? There's 4 thousands. Okay, are there any multiples of 7 that go into 4,000? I don't know, maybe 40 would be something easier to think about. So if I think of this as 4,000, and I think of just the multiples of 7 up to 40, I have 7, 14, 21, 28, 35, 42, 42 goes over it. But I could do that if I think of this as 4,800. 7 times 6 gives me 42. 7 times 7 would give me 49, so that would actually go over it. But 7 times 6 gives me 42. But 7 times 6 equals 42. So then 7 times 60 equals 420. 7 times 600 gives me 4,200, and this is 4,876. I could do 4,200 by multiplying times 600. So 600 groups of 7. 600 groups of 7 gives me 4,200. I can subtract, see what's left. I have 676. Okay, so now I want to think of my multiples of 7 that can go into 67, of course. Love it, 6, 7. Hate it, actually. But anyway, 7 times 6 was 42. 7 times 7 is 49. 7 times 8, 56. 7 times 9, 63. 7 times 10, 70. So we could do 9. We could think of 9. So 7 times 9 equals 63. So 7 times 90 equals 630. And I wouldn't want to go on to 900 because this actually is going to work. So 630 is 90 groups of 7. So 90 times 7 gives me 630. We are left with 46. Okay, we can go back to our 7 times 6, which we already have over here. We can call this a math menu. We have actually explicitly taught about math menus in the past, but I haven't this year. But this is a great thing to do. Have some scratch work over to the side. It doesn't have to be perfect. This is not a work of art. This is math. We're supposed to experiment. So then 6 more groups of 7 can come out of this. 42. Write your 6 there. We have 4 left over. We can't take any more groups of 7. So we're going to add this together. 600 plus 90 plus 6 equals 696. And we have a remainder of 4. Okay. I know that's a lot. But if you have any questions, shoot me a message. Reach out. We will be continuing to work on this as much as we can for this week and next week, all along with Christmas parties and Christmas festivities and everything. So if you have any questions, once again, reach out. Y'all have a great weekend.